am here with Heidi Brewer, who is the operations lead for Beam. Beam, of course, is the Bigelow Expandable Activity Module that arrived on April 10th and is getting ready to be expanded for the first time. So we are here with Heidi, and she's going to tell us a little bit about what has to go on between today and its actual scheduled expansion on Thursday. Beam was installed on Tranquillity last month, right? So what's been going on since then to get it ready for this expansion?
So since then, on the ground, we've been reviewing our procedures and getting ready for all the upcoming operations and making sure that the timeline is in good shape. And then on board, Jeff has been performing a lot of our road tube activities. This morning, he actually installed some cables for the laptop that we're going to use for sensor data collection, and then also checked out the deployment controller that will be used for deployment on Thursday.
Okay, so has it been pretty smooth sailing? Any hiccups?
So far, so good.
Yeah.
Operations are going well.
So does that give you a good feeling then about Thursday?
Yes.
All right. So what is actually going to happen on Thursday? How do we expand the module?
So deployment actually has 5 different activities that take place. The first one is we're going to be closing the ascent vent valve. Beam is currently in its depressurized state, and so we need to close the valve first. Then after that, we'll be cutting the restraint straps that's holding the module in its packed configuration, and then the forward bulkhead will be released. Then we'll go into expansion, which is the expansion from its packed configuration to its full shape, and then lastly it'll be pressurized. So this will be mostly performed by the crew.
Okay, so you said close the vent valve. I'm guessing that's just basically a hole that is currently keeping it unexpanded so that you make it solid, I guess, so that you pump air into it and then it expands, or how does that work?
So it actually is currently open to keep Beam at a vacuum, and then it will be closed so that we can provide air through a different location. That's through the hatch.
Okay, and then you mentioned restraint straps have to be cut. How does that happen?
So most of the sequence will be performed by using the deployment controller that Jeff checked out this morning. Most of it is an automated sequence. Then we'll pause after the first couple steps. Then he will perform some manual expansion through the hatch. And then we'll complete it by doing pressurization, which is using the controller again.
Okay, so what's the difference between manual expansion and non-manual, I guess, robotic?
So the manual expansion is the first portion, which is going to take us from the pack configuration to the full shape. So we'll be able to see the beam basically at its full shape, and then the pressurization, that last part of the expansion, will take it from a lower pressure to its full pressure.
Okay. What does Jeff have to do for the manual expansion? Is it just pressing buttons, or is it anything out of the ordinary?
He'll be opening and closing a valve, and he's using equipment that he's used for a number of other missions.
Okay, interesting. All right. Well, how much bigger will it actually get? Can you give us an idea of how small it is now and how big it'll be at the end?
So once the beam is fully expanded, it's going to be a little under 4.5 times its current volume. So it's going to be expanded quite a bit.
Yeah, and then once it's at its optimal volume, is it roughly the same as the other modules on the space station, or a little smaller?
It's a little bit smaller.
Yeah, but still big enough for a person to get inside, I'm sure.
Yes, that's right. And we'll be outfitting it with a number of different sensors.
Okay. What will the sensors do?
We'll have sensors to collect information on radiation and also impact detection to see what the MMOD is like in that area of the space station.
And MMOD, just for people who don't know, is micrometeoroid orbital debris?
That's correct.
Okay.
And then also temperature, if I haven't mentioned that one.
Okay. All right. So for the orbital debris detection, I guess that's important because this is not our standard module. We want to know how it reacts if it is hit by orbital debris, if we would expect it to leak, that sort of thing. Is that part of the whole point of having Beam on the space station?
Yes, it's just taking a look at how Beam performs compared to the standard aluminum module.
Okay. What kind of feedback will you get on that? Do we get a warning when it's hit, or tell us what to expect?
The sensors will be polling and collecting data over a period of time, and most of the data is going to be sent over to a laptop that's housed in Node 3. And then the ground will send a command up to get the information down to the ground, and it'll be analyzed by the analysts on the ground. The crew will also go inside and retrieve some radiation badges that they'll be deploying every couple months.
Okay, so you mentioned they'll go inside, but they won't stay inside for long periods of time. Is that the intent? They won't move into this one and start living there?
That's correct. It's mostly for sensor data collection.
Okay, so it's basically a demonstration to figure out if this is technology that will work long term in space?
Yes.
Why is that important? Why do we need to know?
Because the expandable feature of this module is that it takes up a little bit less space to get to orbit. It's a little bit less mass to get to orbit. And so if we're able to utilize it in the same way that we do our traditional aluminum modules, then it may be game-changing in the future for future exploration.
Why is that? Why is it important to have the smaller ones available?
We should be able to send more things up into space and do more science and more research.
Great. That sounds very promising. So you mentioned that the crew will be taking some samples over the next couple of years, right?
Yes, the next 2 years.
Okay. How often would you say? And how will they take them? Is it similar to the other samples they take at the space station, or?
Yes, it'll be very similar, actually. We'll be collecting information on microbial samples, so both surface samples and also air samples, and then the radiation samples.
Okay. All right. Well, tell us just what your role in all of this is.
So I am the operations lead. I've been helping put together the timeline and sort of telling the story of Beam and integrating it with the operations team. So looking forward to having it actually come together in space. It should be exciting.